Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 5 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with the today's problem. Problem number 3432. Count partitions with even sum difference. So I'm going to solve this problem using two approaches, and second approach is going to be very interesting. So please watch this approach, second approach, right? First approach, I will not take much time. I will just simply paste the code and I will explain what is happening. But second approach is actually the way we should solve, right? So here we have to do little bit thinking in second approach. In first approach, it's a normal process which we used to do in many problems. That is nothing but prefix some type logic we will implement, right? So let's read the problem statement first. So you are given an integer array nums of length n, and a partition is defined as an index I where I is greater than equal to 0 and it is less than n minus 1. It is going to split the array into two known empty subarrays. Okay, split the array into two known empty subarrays, right? So left subarray is going to contain the numbers from indices 0 to I, and the right subarray contains the indices from I plus 1 to n minus 1, right? So all the numbers which are in these indices, right? And we have to return the number of partitions where the difference between the sum of the left and right subarray is even, right? Very easy, right? So here if you see this, so here we can partition it like this 10, and in this side I can keep 10 3 7 6. This is one way. Or I can keep here 10 3 10 10, right? 10 10. And here in this side I can keep 3 7 and 6. Or I can do it like this 10 10 and 3, right? And here I keep 7 6. Or I can do it like this 10 10 3 7 and 6, right? So I am partitioning it into two, right? And let's say this is x and this is y, right? This side is x, this side is y. Okay, so I can only partition it into two, right? And these two should be non-empty subarrays, right? So here if you see, if you do this, so here in this side what is the sum? 10. In this side what is the sum, right? So here in this side the sum is 26, right? So 26 minus 10, so we will get 16, which is even, right? Okay, same way here we are going to get 20 and here we are going to get 16, so here also even. Here if you do 10 10 20 23 this side, and here 13, here also sum is going to be even, right? If you just calculate the difference among both, right? And here also if you do 30 and here you get 6, so again difference is even, right? So all four are valid, right, in which difference is even, right? So what we have to do, we have to just simply return 4, right? The four partitions are all this, right? So that's it. This is my output. Very easy, right? Okay, so this is what we need to do, right? Now in approach 1, instead of doing partitions like this and calculating the sum again and again, you can do one thing. You can pre-calculate the prefix sum, right? So how we calculate the prefix sum? So here at this stage we just calculate the prefix sum as the sum of previous elements, right? Until here, so until here there are no elements, so here we used to keep 0. Then until here we keep 0 plus 10 10. Then 10 and this 10 we are going to keep 20 here. Then 20, right? So this is how we write, right? So prefix at I position, we used to write it like this: prefix at I plus 1, let's say prefix at I plus 1. Okay, so we used to write it like this: prefix of I plus nums of I, right? Nums of I, this array, right? So here this 0 plus 10 10, 10 plus 10 20, 20 plus 3 is 23, 23 plus 7 is 30, and 30 plus 6 is 36, right? This is how we write. Okay, so here this is nothing but your prefix array, prefix sum array, right? This is what we used to do, right, every time. So here 0 index, 1 index, 2 index, 3 index, 4 index, and here 0 1 2 3 4 5. So here if nums is having length n, so prefix array is having length n plus 1, if you notice, right? And this formula you apply now, prefix of I plus 1. I plus 1 means if let's say your I is 0, so prefix of I plus 1 means at 1. So at 1 we have sum of previous prefix values and this 10, right? So prefix of I plus 1 denoting the sum until here, right? Prefix of 2 is denoting the sum until here. Prefix of 3 is denoting the sum until here. Prefix of 4 is denoting the sum until here. Prefix of 5 is denoting the sum until here, right? This is what we used to do, right? Now what I can do here, if I do split here, right, here, right, so that remains here, right? So in the left side I can if I do the split at I is equal to 0, if I do the split at I is equal to 0, this is approach 1, that's why I'm not taking much time, right? So if I do split at this I is equal to 0, so here in the left side only this element, right? So left side I have to just take the value at prefix at I plus 1, right? So I is 0, so I plus 1 is 1, so this 10, right? So this 10 is nothing but the value until here in the left side, right? And in the right side I can easily calculate the value, right? So right is nothing but these elements, right? These elements. So prefix of 5, that is nothing but I can say prefix of n, right? Prefix of n is nothing but in this case 5, right? Right, total. So prefix of n minus this I have to subtract, this side I have to subtract, so I can say prefix of n minus prefix of I plus 1, right? This is what I can do. So prefix of n means until here, prefix of I plus 1 means until here, so definitely I will get the sum of this part, right? So prefix of n is nothing but 36 minus prefix of I plus 1 is 10, so 36 minus 1 minus 10 is nothing but 26. So see, this side sum is 26 and this side sum is 10, right? So I easily calculate the sum, right? And then after that, once I calculate the left and right using this prefix sum array, then after that I can just calculate the difference. So maybe I will take math dot absolute value of left minus right, and if the modulus of this with 2, if it is comes out equal to be 0, that simply means that the difference is even. So I will just increment, I will take one count variable and I will do count plus plus, right? So this is my first approach, very easy, right? Clear? So let me show you the code, right? So here see, same thing, n, and here I'm taking one prefix array of n plus 1, right? And prefix of 0 in the starting, prefix of 0 means there are no elements before that, right, initially. So here if you see, initially we are taking 0, right? Prefix of 0 means until here, right? Prefix of 1 means until here, prefix of 2 means until here, right? This you already clear, right? So and here you see n plus 1 I'm taking, right? And here I'm setting it to 0, and here this is a formula which I used. Prefix of I plus 1 is nothing but prefix of I plus nums of I. So here if you see, prefix of I plus 1 is nothing but prefix of I plus nums of I. This is what I am written here. Then I am taking one variable answer is equal to 0. Then I am just running one loop from I is equal to 0 to I is less than n minus 1. Why I am doing here I is less than n minus 1? Because my sub array should not be empty, right? So I have to keep one element in the end itself, right? So that's why. So here left and right I explained this formula, right? And here I'm calculating the difference, absolute difference, and modulus with 2, if it is equal to 0, then answer plus plus, and in the end I am returning answer. So you will be here, right? And this approach is also very fast, right? Of n is going to be the time complexity for this one, right? For this one also, right? Okay, so with this all the test case has been accepted, right? Now let me tell you one shortcut to solve this, right? So that's why this problem is easy, right? Now let me tell you. Okay, so here every time you are splitting your array like this in x and y, okay, here also in x and y, here also x and y, here also x and y, okay. So if overall sum of all the elements of nums array is even, right? If overall sum of all the elements is even, right? So we are dividing the array in two, right, in x and in y. So if I do x plus y and it comes out to be even, right? If it comes out to even, right? So x plus y, let's say it is equal to sum, and if it is even, so when I am going to get the sum even, tell me when I'm going to get the sum even. Okay, so I'm going to get the sum as even when my x is even and my y is also even, right? This is one case, right? So if x is 2, y is equal to 4, then always I am going to get the even sum, right? Clear? And when my both x and y is odd, then also I will get the sum as even, right? So when x is odd and y is odd, then also I am going to get even sum, right? Sum is equal to even, right? Clear? Okay. And here in this case, if you notice, okay, if in this case if you notice, if we have even numbers, right, if we have x as even and if I have y as even, right, so the absolute difference between x and y is always going to be even only, right? If both are even, if both are even, right? And if both are odd also, then absolute difference is also going to be even only, right? Okay, that's what actually I need to do here, right? That's what actually I need to do here. Okay, so let's say if x plus y sum is odd, then in that case how we are going to get a sum odd? When my sum is odd, then how I'm going to get? So maybe my x is even and this is odd, right? This is one case, right? So 2 plus 3, so see I'm getting odd sum, right? Or if this is odd and if this is even, then I'm going to get sum odd, right? But is there any other way to get the odd sum? No. So if I do even minus odd, right, I will always get odd sum, right? Or odd minus even, I will always get even, right? Absolute, definitely I'm doing absolute. Okay, so here also I'm getting odd, right? Odd only, right? So we are only dealing with this case, right? We are only dealing with this case, right? We are only dealing with this case, right? So if overall sum is even, right, if overall sum is even, then answer is possible. Okay, then only answer is possible. If overall sum itself is odd, then answer is never possible, right? Here if x plus y and you are getting the odd sum, and definitely in one side if you have even, in one side you have odd, or in one side if you have odd, or one side if you have even, right? Right. So these are the only case when you are going to get odd, but in both the cases, right, answer is not possible, right? In both the cases answer is not possible. But when your overall sum is even, then what are the different scenarios in which we get even sum, right? So that simply means if x sub array is even and y sub array sum is also even, then I'm going to get even. Or if x is odd and y is odd, then also I'm going to get some even, right? So only in even case answer is possible, right? Only in even case, only in this case, right, answer is possible. So that's what I need to do. So just do one thing here. What is the overall sum of this? Let's use some other pen. What is the overall sum of this? 10 plus 10, 20, 23, 30, 36. Overall sum is 36. So with sum is even, answer is possible. So if answer is possible, so in how many ways I can split this? So I can split this in total 4 ways, total 4 x and y's, right? Combination, right? This x and this y, this x and this y, this x and this y, this x and this y. So only 4. And 4 is nothing but I can say n minus 1, right? N minus 1, right? So this is what I need to do, right? Here overall sum is odd, just return 0. Answer is not possible. If overall sum is odd, answer is not possible. Here overall sum is 8 to 10, 10 for 14 and 20. Overall sum is 20. So if overall sum is even, then just return n minus 1. N minus 1 is nothing but 4 minus 1, that is nothing but 3. That's it. All partitions result in even sum difference, right? So we are always going to get sum is 20, right? And if sum is 20, so definitely I will have something like this, I will have something like this, I will have something like this, right? So here in this case even, definitely if overall sum is even, then only these x and y, uh, they may be both even, right? Or they may be both odd, right? Only this is way, right? Only then I'm going to get sum is even. So this is one liner code, right? So here what you need to do, just create one variable int sum and set it to 0, and here just iterate over all the numbers in your nums array using enhanced for loop, and here just increment the sum value every time, calculate the overall sum, and here you have to return what, if return what, if just do here like this, uh, sum modulus with 2, right? If it is equal to 0, then in that case that simply means if it is even, then return what, you can say nums dot length minus 1, otherwise just return 0. That's it. This is your code, right? Now let's run it. That's it. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.